Okay, we are still on section 5.2. In the previous video, we had discussed how to go through the process of long division when you are dividing two polynomials, and that was kind of a tedious process that you had to go through pretty carefully. We said if you made a mistake early on, then everything from that point forward would be incorrect in your answer. Today, we're going to talk about a different process, a different way of dividing polynomials called synthetic division. Now, when I show this to you, you are going to think that this is dramatically easier than using long division. Because it is, but the trick with synthetic division is it comes with limitations, okay? And so I want to make sure that it's clear that there's only certain circumstances when synthetic division can be used. So let's discuss what that scenario is, and then we'll look at how to actually apply synthetic division. You can only use synthetic division when you are dividing by a first degree binomial, and it has to have a lead coefficient of 1. Let me explain what that means so that it's clear, because it's possible on a test you could be given a division problem and you need to know when the situation would arise that it would be okay for you to use synthetic division. Long division will always work. Synthetic division can only be used in this circumstance. So you have to be dividing by a first degree binomial. So that means the part that would come out in front here has to, first of all, have two terms to it. So if you're dividing by, say, a trinomial or something like that, synthetic division will not work. So it has to have two terms out in front. And then it says it has to be first degree. So first degree means that the exponent on your variable is a 1. Okay, so let me give you an example of a binomial that's not first degree. If you were dividing by, say, x, let me change the color on this so you can see this a little better. If you were dividing by, say, x squared plus 4, okay, it meets the condition of dividing by a binomial, but it's not meeting the condition that it has to be a first degree binomial. This is a quadratic, it's a second degree, okay, and so the exponent on your x, it has to be a 1 to be first degree. And then the other expectation is that the lead coefficient has to be a 1. So let's say that I have a binomial that is first degree, but then if I put, say, a 2 in front so that now my lead coefficient is no longer a 1, that would mean I could not use synthetic division. Okay, so we have to have a 1 in front there. Okay, so let's look at how to do synthetic division. Okay, the steps are listed right here, but I'm just going to kind of talk you through it. What you're going to do at the beginning is you're going to grab the constant that's in the binomial. It's a -4. You're going to make that the opposite sign. Okay, so I'm going to make that a +4, and I'm going to kind of enclose that in a little portion of what would look like maybe part of a box there off to the side, okay? Then what you're going to do is you're going to write out the coefficients of each term. Okay, so by coefficient, I'm talking about just the numbers that are in front of the variables. You're not writing the variables themselves. So you're going to write 2, and then leave a little space, -13, 26, and you do also want to write the constant. Now, if this was not in perfect descending order like we have here, if it skipped one of the terms, you would then fill a 0 in as a placeholder, similar to what we did in the previous video on long division. Okay, so once again, these are just the coefficients, has to be in descending order here, okay? Then what you will do is you're going to give yourself enough space that there would be like kind of an empty row underneath those numbers, and you're going to draw a horizontal line, okay? Okay, now what you will do to start the synthetic division process is you're going to drop down the very first lead coefficient, the 2, okay? You're then going to take that 2 and you're going to multiply. You don't flip the signs on anything when you do synthetic division. So you're going to take that 2, you're going to multiply the 2 times the 4, and you're going to write that answer underneath the negative 13. Okay, so 2 times 4, I put my answer in the next column, the 8. Okay, again, I'm not changing the signs. This 8 is positive. Now you're going to just add these two numbers together. So negative 13 plus 8, that is going to be a negative 5. Okay, then I repeat the process all over again. Now I'm taking this negative 5 and I'm going to multiply that negative 5 times the number I have in the box, the 4, and I'm going to fill that in under the 26. So that would be a negative 20. So the pattern is the number underneath the line gets multiplied by the number in the box, and that answer gets put in the next column. You add those together, and then you repeat that number below the line times the number in the box. That gets put in the next column. Okay, again, no flipping of any signs. You simply add positive 26 minus 20, you get 6, and now this 6 gets multiplied times that 4 and gets placed underneath the negative 24. Okay. When you add the very last column together, and you can see in this example, these are going to add together to be a 0. What you're going to do is you're going to kind of box off that very last answer from that last column. That number represents what your remainder is in this problem. So in this particular example, there is no remainder. Okay, now how do you write your answer? Because keep in mind, all of these problems can be done using long division. So when we do long division, our answer isn't just a series of constants or numbers. There are variables in them, okay? And so what we want to make sure that we're doing is that we're reinserting the variables back into the problem, okay? I should highlight this. This is very important. It says, the power of your very first term in your answer is always 1 less than the degree of the dividend. So what this means is if your original problem was, in this case, a cubic, okay, it was 3rd degree, then our answer should now be 1 less than that 2nd degree. So this very first number, the 2, would be the lead coefficient in front of the x squared, and then from there it just goes down one term at a time, minus 5x to the first plus the constant 6, and we said there was no remainder on that, okay? So once again, it's always 1 degree less than what you started with, okay? That's the part that I highlighted here. Okay, so let's go ahead and try another one here. We're going to set this one up. I'm going to do the opposite of negative 3, so I'm going to make that a positive 3. Okay, I notice that this is a cubic, but it only shows me for x cubed and x squared. It doesn't show me x to the first, and it doesn't show me the constant. So when I'm filling in just the coefficients here, I'm going to need to put 2 zeros in, 1 to hold the place for x to the first, and 1 to hold the place for the constant. Okay. Then we start the process by dropping down our first number underneath the line. We're going to multiply that 2 by this 3. We get a 6. Now we combine negative 4 and 6 together, we get 2. We take that number that's below the line, we multiply that by 3, which we get a 6 again. We combine 0 and 6 to get 6. We multiply 6 times 3, we get 18. We combine 0 and 18 to get 18, and then we box off that last value there. That is representing our remainder. Okay, now remember what we highlighted. Your answer is always the power of your first term in your answer is always 1 less than the degree of the dividend. So this started out as a cubic, so that means my answer should be 1 less than that, a quadratic. So it's going to be 2x squared plus 2x plus 6. And then remember how we did the remainders with long division. We always wrote those as a fraction. Okay, the actual remainder portion goes in the numerator of the fraction, and what you place in the denominator is what you were dividing by. Okay, so what's going to go here in the denominator is going to be the x minus 3. Okay, the idea here is whether you do synthetic division or whether you do long division, the answer should be exactly the same. Okay, and you can see in both of these scenarios, we definitely are meeting the criteria to be able to use synthetic division because we're dividing by binomials, that were definitely first degree and also had lead coefficients that were 1. Okay. All right, let's go ahead and try just a couple more here. When you get the hang of this, you can move through these actually pretty quickly here. Okay, so we're going to do the opposite of -2, that's +2. I want to make sure this is in descending order. It looks like it's not skipping any places, so I don't need to insert any placeholders for this particular problem. Okay, then we're going to drop down the 3, multiply 3 times 2, we get 6. Add -8 and 6, we get -2. Multiply -2 times 2, we get -4. Combine 11 minus 4, we get 7. Multiply the 7 times 2, we get 14. Add -14 and +14, we get 0. Okay, so for this one, that 0 is representing your remainder, so there is no remainder. Okay, so we just need to write our answer with the variables back in. This is just a coincidence that most of these have started out as a cubic. Okay, when it starts out as a cubic, your answer will be a quadratic, so it's 3x squared minus 2x plus 7. Okay, last one here. Okay, I'm going to flip the sign on that +2, make it a -2. Ooh, looks like we've got some placeholders here we're going to need to insert. It's skipping a cubed and it's skipping a. So I'm going to need to put 4, 0, 2, 0, 12. Okay. All right, we drop down the 4. 4 times -2 is -8. Add 0 and -8. -8 times -2 is 16. 2 plus 16 is 18. 18 times -2, -36. 0 plus -36, -36. -36 times -2 is 72. 12 plus 72, 84. Our remainder on this problem is 84. Okay, now this problem started out as a quartic, okay, 4th degree. That means this answer should be a cubic, 3rd degree. So it's going to be 4x cubed, and then it's just going to drop down by 1s as you go. Minus 8x squared plus 18x minus 36 plus, and then the remainder goes in the numerator, and the original binomial you were dividing by, that goes in the denominator. Okay, in terms of